The objective of the experiment is to determine the charge on two charged pieces of tape and calculate the approximate amount of excess charge on one piece of charged clear tape. This is accomplished by experimentally determining the charge sign of the pieces of tape and then the magnitude. The charge sign of the tape was experimentally determined to be positive by checking if it repelled or attracted to an object with a known charge. In this experiment, the object with a known charge was a negatively charged pen that was charged by rubbing the pen against fabric. The magnitude of the charge was experimentally determined by levitating two tapes over one another by balancing the gravitational force and electrical force of the tapes. The distance at which the tapes levitate is noted and used for subsequent calculations. Fundamental physics principles include that like charges repel and opposite charges attract, the equation of force equals mass times acceleration, and the equations for calculating the electric field and the force caused by the electric field are all shown here on the slide. All of these principles and equations help us to determine the magnitude of the electric field by algebraically and experimentally balancing the net gravitational force and net electrical forces of two pieces of tape. The subsequent slide, which includes my code and model, will outline the algebra of how it's done. The code for the glowscript model, along with the algebra, is given on the left-hand side, while the model and conclusion questions are answered in the window on the right-hand side. Each sphere represents a piece of tape modeled as a point charge. The green arrows are the net force experienced by the particle as a result of the product of the net electrical field and their respective charge, Q. The red arrow is the net gravitational force experienced by the top piece of tape. As can be seen, the top piece of tape levitates because the net electrical force experienced by the point charge pushing it up is larger than the net gravitational force pulling it down, experienced by the point charge. Through using the model, correct equations, and performing simple algebra, it was concluded that the charge on the top tape is 2.20362 e to the negative 8 coulombs. The top tape is deficient by 1.37726 e plus 11 electrons. There are a total of approximately 3.04 e plus 17 atoms in the piece of tape used. The ratio between deficient electrons to atoms on the tape is 4.53047 e to the negative 7, or 2.2072 e, 8 e plus 6 atoms for every deficient electron. The assumptions that enabled me to perform these calculations were that the tape behaves like a point charge and we assume all electrons are evenly stacked end to end along the tape. Some additional questions in the lab are as follows, and I will answer them now. Number 1, it should attract because the pen will be negatively charged. Number 2, if the tape is negatively charged, then the negatively charged pen will repel the electric tape. Number 3, the induced dipole will cause attraction. Number 4, the tape is positively charged, it attracts the pen and repels the glass rod. Number 5, it's in the positive y direction and moves up/away from the tape that is below it. Number 6, the earth and the tape below it. 7, you need the mass. The mass of my floating tape was 0.22 grams. Number 8, it is reasonable that they have the same net charge because they are made of the same materials and prepped the same way. Number 9, because if you are to touch the charged tapes, they will lose their charge to what they have contacted. Oh, and I can't stop it.